Alright, welcome. We're talking about families of graphs today, and this is just like in Algebra 2 when you did families of graphs, except this one we're going to be looking at this other function called the greatest integer function. So if I go back to my calculator and I get rid of all these bad boys, okay, and let's sign in. Boom, bada bing, bada bing, bada boom. Okay, and let's go to families of functions. Okay, so opening up families of functions. Okay, you can see all your functions, and you can see that there's variables in all places. So a is being multiplied in front of all these functions. H is being added inside. B is being times by the x inside, and k on the outside. Okay, now B and H are going to do two things. Okay, so A, if I increase it to be bigger than 1, it vertically stretches it. If I decrease it to be less than 1 but greater than 0, it vertically compresses it. And if I make it negative, it just flips the graph about the x-axis. So it flips it upside down. It does not flip it sideways, please. That's hugely important to a lot of people. Okay. Okay. Alright, now the B equals, the B line, if you notice, if I mess around with it, it horizontally compresses it and stuff. It just kind of pushes it in. Okay, so that's what we call horizontal compression. But it also works in tangent with this. So normally, when I make H positive, it moves the graph to the left. If I make it negative, it moves it to the right. Pretty simple. So if I move it to the right 3, I'm moving my graph to the left 3. Alright, but if I do this, if I start increasing this number, it decreases the amount of steps I take. So in other words, to go a total of 3 units, I need to go 6. No, actually 9. Who am I kidding? Alright, so if you notice, just to go to this one spot right here, I used to have to just make H a plus 3, but now because B is right there, it's because of that. Okay? Alright, so B greatly influences how the graphs move. Okay? Alright, now K, obviously, nothing really affects this because it's outside of the function that's being added or subtracted. So it moves the graph up or down. It's called the vertical translation is what we call that. Okay? Alright, but there is some more graphs that I do want to talk about, and that's the greatest integer one. So y equals a times, no, we'll do floor of bx plus h plus k. Okay, so what I'm going to do is I'm going to turn off all the other graphs, and this is the greatest integer function. Pardon me. Okay, so the greatest integer function, this one's the floor function. Okay, so the floor function actually has the same kind of properties. If I increase a, it spreads it out vertically. If I make it negative, it flips it upside down. Okay, so that one's pretty cool. Okay, now if I do B, it's going to compress it horizontally. Okay, if I make it negative, it's going to flip it about the y-axis. So that's kind of cool to know. Alright, the H obviously is going to move it left. If I make it positive, it still follows the same rules as everything else. Okay, and K, same thing. Now this one's going to give the illusion of moving left to right, but in fact it's moving up and down. Okay, now the greatest integer function is saying, basically, if I plug in, here, let me, y equals floor of x. Nope, let's go parentheses x. You have to actually say that. Okay, Now right here, this is just x. So whatever I plug in for x, I'm going to round down. So if I plug in, if you notice on my graph, if I plug in 0.28, I'm rounding down to 0. If I plug in 0.75, I'm rounding down to 0. If I plug in 1, I'm rounding down to 0, but that's actually should be an open dot. That should not be included in there, okay? Alright, now if I go up here, if I go up to 1, I round down to 1, obviously, and then all the way. And so it's almost like the steps of a staircase without this vertical component to it. It's just got the horizontal components. Now if I change this to ceiling, and all I need is CIL, okay, it's going to round everything up. So if it's at 0.1, it rounds up to 1 if it did anything, and it just keeps doing that and just keeps doing that. So it's kind of cool how this stuff works. Now there's also another one, a greatest integer called round. You guys are probably going to be using the floor one a lot, so just so you know. This one rounds to the nearest integer. So like for example, if you notice, it's kind of like shifted over like half from the floor. Okay, so if we're at negative 0.5, we're going to round up to 0. Makes sense. If we're at 0, we round up to 0. Okay, and if we're at anything less than 0.5, we're going to round down to 0. Now, if we're above 0.5, let's say 0.51, we round up to 1. And we just keep doing that and keep doing that and keep doing that and keep doing that. And it's just going to show up that way. So that is the greatest integer function. Okay, and just know your rules. The A controls the vertical compression. The B controls the horizontal compression. In other words, are you squeezing? The A is stretching up and down. The H moves left and right, but opposite of what you think. And the K moves up or down, just the way you think. Now, if A is negative, you would flip the entire thing about the y-axis. I'm sorry, the x-axis. And if B were negative, you would flip the entire thing about the y-axis. So that's kind of cool to know. All right, but that's everything you need to know about families of functions, and it also works for the greatest integer function. So you guys have a wonderful day, and I will talk to you later. Bye.